Okay, so something extra that you Chem 30s need to know after we've now talked about pH and POH and the pH and POH scales is that that was mostly a review for you guys from Chem 20, and that there's a little bit of extra stuff that you need to know as it relates to those scales. So really quick, here we've got this concept of the ion product of water. And so what turns out to be is actually water is in an equilibrium reaction with hydrogen ions and hydroxide ions. So in a glass of water, there will be some hydrogen ions and some hydroxide ions. And if you remember from the previous video and the pH and POH scales, if you look at the concentrations of both of those, the concentrations of H plus and OH minus are determined for a neutral solution. We know that water is neutral, and so those concentrations are set. If the pH is 7, then the concentration of H plus is going to be 10 to the negative 7, and the concentration of OH minus is going to be 10 to the negative 7 moles per liter. So this is just the Kc expression of water. Now, because water is such a common substance, it's a special substance to life on Earth or whatever, I guess long ago, somewhere, sometime, scientists decided that instead of just giving water a Kc value, we're going to give it a special name. And instead of calling it just Kc, we're going to call it Kw, just for the Kc of water is essentially all that means. So it is a Kc value still, it's just a very special type of Kc, which is, this is the Kc of water, and we call it Kw. And this is the ion product of water, or in other words called the dissociation constant. And so this can be calculated, this is your formula right here. We know that the concentration of H plus is 10 to the negative 7 moles per liter. Or we could say 1 times 10 to the negative 7. And the concentration of hydroxide ions in water is also 1 times 10 to the negative 7, or just 10 to the negative 7. So you plug that into your calculator, and the Kw comes out as 1 times 10 to the negative 14 moles per, Kc value, so Kc's don't have units. It's just 1 times 10 to the negative 14. And that is Kw. This number here is found in your data booklet, so it's not one that you need to have memorized, but you do need to know how to use this formula, and this formula is not in your data booklet, so you do need to have this formula memorized. And what you can now do, and I won't go through specific examples, I'll just kind of show you how this works, is that anytime that you're given a hydrogen ion concentration, you can use this formula, because you know what Kw is, it's this number. You can now just algebraically solve for your unknown hydroxide ion concentration. Or conversely, if you're given a hydroxide ion concentration, you can algebraically solve for the hydrogen ion concentration of that same solution. And so you'll be asked to do that in some of your practice questions. And that's it. Thanks for watching.